Hello folks, and a very warm welcome aboard. It's your Captain Joe, and today we're diving into a crucial aspect of helicopter flying, mastering helicopter climb performance. This is a topic that every aspiring pilot needs to grasp thoroughly to ensure safe and efficient flights. Understanding how your helicopter climbs is about safety, efficiency, and making informed decisions in the cockpit. It's not just about pulling the collective and hoping for the best. It's about knowing your machine and the environment you're flying in. A good climb can mean clearing obstacles with ease and reaching your cruising altitude smoothly. Whether it's trees, buildings, or other aircraft, knowing how to manage your climb can make all the difference. Climb performance impacts every flight phase from takeoff to reaching a safe en route altitude. It's a continuous process that requires constant attention and adjustment. In this lesson, we'll break down climb performance into easy-to-understand segments. We'll cover the basics and then move on to more advanced techniques. We'll look at factors affecting your climb, from the air you're flying through to pilot techniques and helicopter condition. Weather, weight, and even the health of your helicopter play crucial roles. We'll demystify critical airspeeds like Vy and Vx, essential for optimizing your climb. These speeds are not just numbers, they are vital for achieving the best performance from your helicopter. Our journey will also cover the effects of wind on your climb and how to use torque settings effectively. Wind can be both a friend and a foe, and knowing how to manage it is key. So, buckle up, get your notebooks ready, because this is going to be an informative session designed to elevate your flying skills. We'll provide you with practical tips and insights that you can apply in real-world scenarios. Let's get started on this important topic. Your journey to mastering helicopter climb performance begins now. Let's talk about the elements that dictate how well your helicopter climbs. Turbulent air disrupts airflow over rotor blades, requiring more power to maintain a steady climb. Pilot techniques play a huge role. Smooth and precise control inputs are key. Maintaining the correct airspeed for the desired climb type is critical. The condition of your helicopter is another major factor. An engine not producing rated power or rotor blades with damage will reduce climb performance. Regular maintenance and thorough pre-flight inspections are fundamental. Density altitude, affected by altitude, temperature, and humidity, impacts climb capability. Hot, high, and humid conditions mean less dense air, reducing lift and engine performance. Always calculate your density altitude and consult your performance charts. These factors ensure your helicopter performs as expected during critical climb phases. Let's get into important airspeeds, Vy and Vx. These two speeds are crucial for efficient and safe helicopter operations, especially during critical phases of flight like takeoff and climb. Vy is the best rate of climb speed, gaining the most altitude in the shortest time. This speed is essential when you need to reach a higher altitude quickly, such as when avoiding terrain or weather. Vx is the best angle of climb speed, gaining the most altitude over a short distance. This is particularly useful when you need to clear obstacles that are close to your takeoff point. Vx is used to clear obstacles shortly after takeoff. Imagine taking off from a confined area surrounded by trees or buildings. Vx helps you ascend steeply to avoid these hazards. Visualize using Vx to clear trees at the end of a short field, then transitioning to Vy for a faster climb. This combination ensures both safety and efficiency during the initial climb phase. Specific values for Vx and Vy vary by helicopter model, weight, and conditions. Always refer to your helicopter's manual to find these critical speeds. Understanding and using Vy and Vx correctly is crucial for flight safety. Proper knowledge and application of these speeds can make a significant difference in emergency situations. Using the wrong speed in a critical situation could have serious consequences. It could mean the difference between a safe climb and a dangerous encounter with an obstacle. Always know your aircraft's specific Vy and Vx speeds for the current conditions. Regularly review and practice these speeds to ensure they are second nature during flight. Apply them appropriately to the phase of flight and the environment you are operating in. Mastery of Vy and Vx will enhance your overall flight performance and safety. The windy challenge. How air movement affects your climb. Wind significantly impacts your helicopter's climb performance. Airspeed is your helicopter's speed relative to the air mass, while ground speed is its speed over the ground. A headwind reduces ground speed, effectively steepening your climb angle. This helps clear obstacles by achieving a better angle of climb over the ground. A tailwind increases ground speed, shallowing your climb path. This can be problematic for obstacle clearance. Understanding wind direction and speed is critical for planning takeoffs and climbs. Always obtain the latest wind information and factor it into your performance calculations. Ground speed and climb angle over the ground are crucial for navigating safely. Be aware of how the wind affects your flight path, especially during the critical climb phase. Powering up torque settings and using performance charts wisely. Managing engine power effectively is paramount, with torque as the primary indicator. Use high power settings for climbs but stay within published limitations. Exceeding limits can lead to costly repairs or in-flight emergencies. Performance charts predict climb performance based on factors like pressure, altitude, temperature, and weight. These charts help determine if a planned flight is feasible and safe. On hot days at high altitudes, climb performance is reduced. Charts quantify this reduction, allowing informed decisions. Always be conservative with performance charts and build in a safety margin. Proper use of torque settings and performance charts ensures safe and efficient climbs. Putting it to the test, practical climb performance calculations. In this chapter, we will delve into the essential steps and methods for accurately calculating climb performance in helicopters. Understanding these calculations is crucial for ensuring safe and efficient flight operations. Let's work through sample problems to apply performance chart information. These examples will help you grasp the practical application of theoretical knowledge, making it easier to perform these calculations in real-world scenarios. First, determine the expected rate of climb. This is a fundamental step that sets the stage for all subsequent calculations. Locate the performance chart for rate of climb in your POH. The pilot's operating handbook contains all the necessary charts and data for these calculations. Find the pressure, altitude, and OAT intersection to read the expected rate of climb. This intersection point provides the specific rate of climb for given atmospheric conditions. For example, at 4,000 feet and plus 15 degrees Celsius, the rate might be 750 feet per minute. This example illustrates how environmental factors influence climb performance. Next, calculate time and fuel for a climb from 2,000 to 8,000 feet. Accurate fuel and time calculations are vital for flight planning and safety. Use the time, fuel, and distance to climb charts. These charts provide a comprehensive overview of the resources required for the climb. Subtract the time and fuel for sea level to 2,000 feet from sea level to 8,000 feet. This step helps isolate the specific requirements for the desired altitude change. For instance, 10 minutes and 15 gallons minus 2 minutes and 3 gallons equals 8 minutes and 12 gallons. This calculation ensures you have a clear understanding of the fuel and time needed for the climb. These calculations ensure enough fuel and accurate arrival times. Always double-check your calculations. Double-checking helps prevent errors that could compromise flight safety. Practical application of these principles is key to safe flight planning. By mastering these calculations, you enhance your ability to plan and execute flights safely and efficiently. Mastering the climb key takeaways for every pilot. A successful climb depends on interconnected factors. Correctly applying Vy and Vx is fundamental for tailored climb profiles. External conditions like turbulent air and wind significantly affect your climb. Smooth control inputs, precise airspeed management, and proper power settings are essential. Maintaining your helicopter in top condition ensures performance figures are achievable. Diligent use of torque settings and performance charts is non-negotiable. Mastering climb performance combines theoretical knowledge with practical skill and sound judgment.